So now we have check single number column. Just to give you some clarity here, so you have IKJ and JKI for there, and you have IKJ and IJK for rows. So essentially is you've got your rows, columns, and options. You want to write for IKJ, and then you can either write Sudoku IKJ, I think it's IJK. There's a big difference in how this passes through its data, so just be careful of that. But essentially, just moving the loops the right way around can stop it from a check rows to check columns. That's by changing them, I think, these two here. Okay, so let's look at the columns now, because the columns is actually quite special. That's where the first code came in. So you see here we have a single for 9. That was a note I'd left myself by printing out. We have this here, and you can play around with this code if you want to later. So what I did, because I knew it was interesting, I wrote down every Sudoku. So for row 0, let me make a note right here. We are in column 0. Column 0. These are all the cells. So in column 0, we have 1 happens 1, 2, 3, 4 times. We have 2 happens 0 times. We have 3 happens 0 times. We have 4 happens 1, 2, 3, 4 times. 5 happens 0 times. 6 happens 4 times. 7, 0, 8, 0. But look at number 9. Number 9 only occurs 1 time. Okay. I'm thinking to myself, if 9 can only occur 1 possible time in this whole cell, and if there was a 9 already, like you can see here, the 0 for 2, the 0 for 3, the 0 for 5, 7, and 8, they have already been hit. So we've already eliminated these possibilities. So if there is a cell, a 2 cannot exist ever again because there's 0 possibility of happening. But 9 can happen 1 time. And now that we know 9 can only exist in this cell because of our building upon itself, 9 must be correct. Therefore, U must become a 9. And this is where, right now, we're still trying to eliminate a few possibilities. Like, before we brute force it and backtest it, let's try these simple solutions. Let's try this basic principle and see if we can make progress this way.